Use the graphing calculator to graph this polar function. So change the mode to polar. And now when you go to y equals, it's instead going to say r equals. And then cosine of 2 theta. The biggest that cosine gets is 1. So I can change, well, first of all, the theta go from 0 to 2 pi. And then for x values and y values, -1 to 1 is enough. And then take a look at the graph. And it's what's called a 4-petaled rose. I know it doesn't look like a rose, but that's what they call it. So anyway, looks more like a daisy or an iris. So now we need to convert to rectangular coordinates. You can use these formulas. So just set up a little right triangle in case you forget the formulas. This is x and this is y. So we're changing from the x and y system to the theta and r system. Or in this case, we're going the other way around, going from r and theta back to x and y. So we have things like sine of theta. Sine is opposite over hypotenuse. Or if you solve for y, it's going to say y is equal to r times sine of theta. Likewise, cosine of theta is adjacent over hypotenuse, or if you solve for x, x is equal to r cosine of theta. And so with this one, it's got a 2 theta, but both of these have just theta. So we need an identity that is going to get rid of the 2 theta. So we can have r equals, and then an identity for cosine of 2 theta is cosine squared of theta minus sine squared of theta. And sometimes we use it in this form, that y equals such and such and x equals such and such. Sometimes, such in this case, we've got, okay, cosine is in there and sine is in there, so use the top two. So we're going to need to square both sides to get sine squared, square both sides to get cosine squared, and then substitute those in here. So we've got cosine squared is x squared over r squared. Sine squared is y squared over r squared. And then we've got an additional r over here. And we're going to need to replace r and have just x's and y's. So you can also use the Pythagorean theorem. X squared plus y squared equals r squared from that right triangle. And then replace each of these r squares. So x squared over x squared plus y squared minus y squared over x squared plus y squared. And then r is equal to the square root of x squared plus y squared. And then we could combine this side, so it would say x squared minus y squared over x squared plus y squared equals the square root of x squared plus y squared. And we're not really going to be able to simplify much beyond that, so it's just going to have to be that. So part of the point of using these other systems, parametric and polar, is in calculus, would you rather deal with this function or would you rather deal with just that function? Well, this would be much easier to deal with when you're talking about derivatives or integrals. This would be quite a mess.